All right, good morning. This is July 24, 2025, Fanshawe College Network Cabling Class ELEC 1013. This is week 11. And today we're going to talk about the security, fire, and surveillance. As I keep saying, this network cabling class is not just about, I hope you found out this by now. This is not just about running a cable from point A to point B and terminate this thing at both ends, because frankly, that we could just do in 1 week. The whole business of the network infrastructures is, I would say, more vast than just than things meet the eye at first, as far as scratching the surface. All right, you will be if okay. Again, I'm assuming the only way I can teach this class is assuming that somebody's going to get a job in this field. So I keep saying that. So when you get hired in this type of field, I call it the modern telecommunications, but it's a really unofficial term. This is just my terminology. This is network infrastructure, so it's part of the IT. So it goes with a little bit with the IT, a little bit with the construction and the mechanics that have to do with that. And I don't mean the mechanics as far as the gear ratios and stuff. I'm talking about the topic. All right, so a little bit of construction. Little bit of electronics troubleshooting, maybe designing some systems, whatever your strengths are, you can find yourself within this field. And plus, this field is so vast that if you decide that you're interested in fiber optics, you can just go into the fiber optics, focus on that, and you can find your niche there. And if you just want to do with telephony or security or fire alarms, a little bit different because you need some additional licensing for that, or surveillance or sound systems and other things. You can find your niche and do just that. However, when it comes to big companies like those giants, like for example, Rogers, Bell, Telus, and things like that, Kojako or ExecuLink, whatever, right? Those big giants, usually things are organized there in a way that you will be put into certain departments and you will learn how to do less things, but do them really well. And that's how those big companies work, and that's awesome, right? Now, when it comes to working for yourself or being hired by small business, so-called small business. However, I'm not sure the small business thing should be redefined because some of the companies that are considered to be small business don't seem to be that small at all. All right. So then, but let's just say small business type of thing. Then you will be exposed to pretty much everything. All right. You'll be whatever the contracts the company gets, then that's what you will do. Now, of course, some companies will specialize in certain things when they get some bigger contracts with some other bigger companies. So that's possible too. However, you will be after working a few years, you will have a lot of knowledge about configuring certain systems, the terminology, and of course, the new things are going to be coming up, new technology, new connectors, new procedures, or whatnot. So it's an ever evolving field. So let me just get you some of the start you up on certain things that you might encounter during that quote unquote, I say, journey. Okay. All right. So we'll talk about the security alarms first today. Okay. Where's my F5? Here's my F5. Good. So when you have that presentation downloaded, I would encourage you to watch some of these short videos, and they show a little bit of, like, this one here is showing something that's called a water detector. This one shows different types of keypads, and this one shows I forgot what it was. It's a paradox system. Well, let me just quickly take a look at that. All right, I'm just going to, because I don't want to lie to you. Of course, I have to go to the commercial. Um, oh yeah, this is talking about motion sensors. All right, so that's fine. Now, as we go along, I will be presenting certain concepts of security alarms and some other systems as we go along. All right, so yeah, this will give you some more insights or on some details of things. But as we go along, I'll explain those anyways. All right, so this is an example of a so-called main board, or some people might stretch that into calling it stretch things into calling it the motherboard, but things like that usually are called main board of one of the leading producers of security alarms. By the way, if you're interested in pursuing your career within any of the topics that I'm talking about, and may I say, I am not teaching you, and I'm teaching you a lot. I'm showing you a lot. There is not a single thing that I'm teaching you that I haven't done before. I have done, and it's not just like 1 or 2 days. Seriously, I was doing those things and still do to some point, because you can't never shake the old clientele, which is awesome. I love the people I used to serve, and they love me. So yes, if they need some service, I will, I'll come to their aid. If you're ever interested in any of this stuff, talk to me. I will set you up. I'm not going to do stuff for you, but I'll tell you what doors to knock, what questions to ask, what procedures to follow in order to set yourself up with a legit business. Okay? All right, so we have a bunch of electronic parts, surface mount components, and all that stuff. Let's take a look at what's going on here. Over here, of course, the first thing that jumps at us, one of the first things, is the battery. This is the battery that keeps all the memory. Now, all their systems, all their security systems, you could just do certain simple programming just through the keypad. And the programming structure was more simple, but there were less features, and there were less possibilities of interfacing with other systems. Now, this, small board, because that's about, uh, I would say 7 inches by 4 inches board, something like that, or 5 inches. So it's not that big. However, what's inside there, it's amazing. There's a whole world that's inside the programming and all that stuff with this. Now, the other thing that we can see here, some of the simpler things I'm going to point out here, is the terminal for the backup battery, because security alarms need to have a backup battery. If the power goes down, you want that thing to work for whatever certain amount of hours. And you're going to put it's a lead acid battery, but it's a sealed battery. It has to be done for this purpose, because you can't just have the car battery leaking all the chemicals into the air that you can get possible explosions. So these batteries are specially made, so they're sealed, and they do last anywhere from 4 to 5 years, 6 maybe. Right? So whenever I put a new battery that is, when I replace the battery, I would just, with the permanent marker, I would write on the side of it the date that it was installed. So when things get into trouble, that possibly battery is going bad, doesn't want to charge anymore and all that stuff. I can see, oh yeah, that thing was done 7 years ago. This thing owes you nothing. So let's just, spend $50 and get another battery that's going to last you another 6 or 7 years. All right? Now, the basic questions from the clients always is, you can always expect that question. How long does the battery last when the power goes off? And there's no one specific answer for that, because that depends on how many active devices you have connected to the system. So how many keypads you have, which draw power, how many motion sensors you have, which draw power, how many glass break detectors you have, which draw power. You get it. Any other things like maybe expansion boards or something like that, anything that needs to be powered to work, it will use the electricity or the electrons that are stored in the battery. And the more active things you have, the less time you will have. So when the power goes down, so usually I would say something like an hour to 2 hours. You can say that you might expect, but there's no definite answer. There's no definite answer for anything. Now, this is a little bit of a slippery topic, if I may say that, because alarm system and the clients have to know that. And when I was doing this thing as my own business, I actually had a thing to sign for the client to sign that the client understands that there is no guarantee that this installation of the security system is going to prevent any kind of break-in or situations that might arise due to burglary or things like that. It's an piece of electronic equipment that can fail. It's beyond your control. Things can fail, things cannot work, things can malfunction. Of course, a situation like that is unlikely. However, it is possible. So I would always have that thing. So yes, it's a deterrent. It does work. It does help, and and the help and the work of that thing is actually real. It actually works, but it's not by no means a guarantee that nothing is going to happen. Okay? So yeah, it's better to have it than not have it, and it's just a little bit of understatement, but because these things do work. But as I said, no guarantees. All right, so here's the terminal for the battery. Another important terminal here is among other things, this will be like a memory key, not used as much as before. This was it was a proprietary device, sort of like a jump drive right now that we have. And if you wanted to record all the programming, you would stick that in here into this connector, and you would punch a command in the keypad to upload all the programming information onto that jump drive. It's not a really jump drive, but it was made just for that. And so if there would be some critical damage of this system, you would just get the same board, install it, pop this thing in, and download the programming onto the board or upload. And you would not have to do all the programming. And sometimes programming is complex. You would not have to do this thing from scratch. This thing is not being used pretty much at all anymore, because most of the programming that is done that has to do with the programming of this board is done through a laptop. And of course, when you do that through a laptop, to the software, there are different names of the software. I'm not going to mention that for now. But there are a couple of proprietary software packages that have to do with this. And usually when you do that, of course, you save that on your laptop. So you don't need that memory key right now, because you have that thing on file. And again, something happens, you just push that programming that you have stored. And of course, things are being secured and all that stuff. And you program this thing. You can upload all the programming. Of course, maybe some small changes need to be done. Serial port. Here, this is the one that is still being used a lot. What do we connect to the serial port? Well, two main things. You can connect something that's called a serial interface. And serial interface you can buy in online or in Amazon or any other thing. But usually when you do that, you get this universal serial port. And the serial interface, the serial interface, it's almost like in its own right, a media converter that converts the USB port onto a serial port. Sometimes you need to plug in things into the serial ports of whatever device. Now, with this particular one, you need to buy the serial port from this company here. This one's actually Paradox, and it's a Canadian company. And actually, this one is company of my choice that I used to do that. It's awesome systems, the most innovative, and I'm not associated in any way except that I prefer to buy these systems. So this is not a commercial, but I'm just telling you, this is not. Now, of course, other companies have their own proprietary boards, like Chubb would have their own systems. ADT would have their own systems, and other companies will have their own systems, and they swear by it. That's fine. But if you want to get like a really good working, well done system, Paradox is it. Used to be DSC. DSC is still going strong, so I shouldn't say used to be. So DSC and Paradox are the two main players, I would say, that are available for the regular contractor to use. These are not being sold to public, they're being sold to contractors. So you have to have your own business registered and register your business within a distributor. And then you can get all the goodies that the distributor has to offer from all the brands. You do not buy stuff from directly from manufacturer anymore for like many years now. You register yourself with distributors. And then again, if you are interested in setting up your own business, I will set you up. I will tell you where to go, what paperwork to fill, and all that stuff. It's not really that complicated. It's quite simple, actually. So, but the serial port that has to do with this one has to be done by the Paradox. So it does have this type of straight connector. And also it works as a universal universal serial port anyways. So it works with other things as well, but you need that type of connection here. And the normal ones that you buy normally, they don't have that. Okay? So you can connect your laptop directly to the board. So with that one, with the direct connection, you get on-site. You have to be on site, you have to open the box, and you have to plug in the serial interface to your laptop, and the other end of the serial interface, you plug into the serial port. And then there's a simple procedure of logging into the board. Another thing that is used, that the serial port uses, you could plug in something that's called the IP module, Internet Protocol module, which is a box, really small, actually. I would say maybe 5 inches by 3/4 of an inch. So comparing to the board, it would be, it would be something like that big here. Oh, okay, that big. And it plugs in here, and you can mount that thing in the so-called can or a box above that. So this serial port connects through that IP module, and on the other end of the IP module, you have an Ethernet jack. So you can plug that into your computer network. And of course, you have to set up some passwords and usernames and that, so you could, not just anybody can access this board. But instead of bringing your laptop on site and having to open the box and plugging your serial interface into the serial port, which would be busy anyways because the IP module will be plugged in, you can plug in your laptop into the client's network through Ethernet and then access the board that way. What you can also do, if the IP module is installed, you can set it up so you can have remote access to this board. And in some areas, some rural areas, this idea is very popular, because when, like for example, in Canada, like in the east, Newfoundland, New Brunswick, all those areas, some of the techies do have a vast area to cover. And if it's just if the service call, because sometimes people get called, so there's some trouble, or maybe can we modify some things, normally you would have to go on site and do the programming. But if you have to drive 300 kilometers or 200 kilometers to the client just to do a simple programming change, then of course it's an awesome thing that if you could just do it from the comfort of your own home, log in through internet, through the network, and do some simple programming change. Like for example, the client might not remember how to remove certain user code if one of the employees leave the company. Then their code has to be made inactive, and maybe they forgot how to do this or lost the procedure or something like that. So you could just remotely access that and take care of things. Maybe some new employee is hired, and they need to do that, to program their code. That's fine too. You can do it remotely, or maybe whatever other change. Maybe there was a power outage or something like that, and the system clock has gone off. Deregulated, so you can just fix that. Little things like that they don't require going on site and physically do things to the system, like running a wire, installing a new device. Yes, then you have to drive on site. Okay, so the serial port, mostly those two things are being connected to the serial port. So it'll be a serial interface to connect to your laptop for the direct connection, or connect that to the IP module, which connects to your network, and you can access by plugging into the client's network physically, or remote access through internet. Okay? Now, here's the fuse. One fuse. I would recommend that if you do those things, you just have a bunch of fuses with you, or maybe have some fuses left on site just for this purpose. Because sometimes this fuse goes poof. And this fuse has to do with, in this particular system, it has to do with the backup battery. Okay. And this one is what, 3 amps? No, 3 or 5 amps. I can't say, I can see that here. So just a regular fuse, whatever it says, have few of those on that, so you could replace it as you need. When does the fuse blow? The most common situations I would see is that if this battery here is plugged in backwards, then this fuse goes immediately. It's a good protection. So the rest of the board doesn't go poof. All right. Now the battery has a connector with red and black wire, and it actually says plug in red here and black here, so we can flip the whole connector in order to match the colors. But sometimes people maybe can't see that because it's covered by this connector assembly, or sometimes it just happens that people plug this thing backwards. If client wants to replace their own battery, or even if you do that, then the fuse blows to protect the rest of it. So that's this purpose of this fuse. Now, starting here, we have the AC, which here's the screw terminal connector. Now, I have some magnifications of that, so I'm going to change the slide, and just you see here that the next slide is just this connector right here. All right. So over here, we do have the AC connection, and this is where the main power comes to the main board. It requires 16-volt AC. I don't remember the amperage that it needs. It usually is in the specifications, but you don't need to remember the amperage of that, because the power transformers that you get when you buy this, they are made for that. If you really want to find out what the amperage or the ampacity is of the board, then you can look at the manual as you buy it for your own sake. Also, what other thing you can plug in instead of the plug-in transformer that is being sold by the distributors, and it's a one-size-fit-all type of most of the time. The power transformer, it will power up other boards as well, but also sometimes called a doorbell transformer, the transformer that powers up the doorbell. It's the same thing. It's got 16 volts AC, so you can have that thing as a wired in or plug-in power supply. The plug-in power supply, it's a transformer power supply with the prongs at the front of it that you plug into the regular hydro outlet, and you have screw terminals at the other end, and you just run maybe 18 to 16 to is recommended wire, stranded wire to plug in the AC to the board here. The wire in transformer, which is always I prefer if I can help it. I prefer the wire in transformer because that's the one, it's a doorbell transformer. You mount it onto the electrical panel and wire into the electrical panel, which means you can have its own dedicated circuit breaker for that. And that's the best situation that you can have. Right? Also, the other plug-in transformer, if by accident you short the terminals, that thing blows and there's no way to fix that. Right? So better have some extra ones in your stash. The wire in transformer just blows the circuit breaker if you short it by accident. So now I can see Robert says lots of capacitors to explode with reverse polarity. You're talking about the capacitors here. Yes, that's true. However, we the new capacitors, they can handle a lot reverse polarity because Mr. Giraj and I, we tried to do a controlled failure of one of the capacitors just to demonstrate to the students, and that thing did not want to explode. So some of the capacitors, some of the new capacitors, they have some extra venting protections and whatnot installed. But the older ones, if you reverse polarity on those, you're talking about the electrolytic capacitors like this one here, and there's some smaller ones. They would take about 3-4 minutes to build up the pressure and explode. It didn't have to be a lot of voltage. It just has to be reverse voltage. Yes, that's less. Yeah, that's less fun. Yeah, some of that, electronic, hobbies and stuff like that. Sometimes we would do that just to demonstrate. Don't do that because that's what can happen. Okay. And of course, wearing safety glasses helps a lot. And not, if I may digress, it's not just for the capacitors. If for anything else, transistors, it's a packed material in certain small plastic package. And if something goes wrong with that, this thing bursts. And it's not like a huge, powerful explosion, but it's enough to get some sort of a piece of debris in your eye. And then who wants to deal with that, right? I mean, so capacitors, diodes, resistors, less likely, but anything that is on the board, those components, especially some of the ICs are packed tightly with a lot of things. And some of them, when they burst, they burst. So yeah, wear safety glasses. They are not just for us to keep nagging for you to wear safety glasses. They actually do serve purpose. And I do have stories that I'm not going to bore you with that I could say, yes, they work. Trust me, they work. Okay. And I know some people who didn't wear the safety glasses and they are sorry for the rest of their lives. More than annoying sometimes. All right, so here's the AC part. Then the next thing here we see that's called a bell, and that's the technical terminology for the siren, the noisemaker when the alarm system goes into the alarm condition. When the alarm system goes into the alarm condition, a 12 volts DC appears on these two terminals, and the sirens are designed, the sirens are designed to work, to produce a high pitch, annoying, really unfriendly for us humans sound when provided with 12 volts DC. Right? There are different sirens. There are 15 watts sirens, which can make a lot of noise. There are 30-watt sirens that can make a lot of. You don't want to be standing beside that, you know. And some people double them up. So I would hate to be the burglar that finds themselves in the room with those things going off, because the noise is so loud and the frequencies are chosen carefully by some whatever scientists that it triggers all kinds of responses in your brain that you cannot necessarily control. Panic, confusion, and you just want to get out of there. All right. That's the. So now sometimes you can put a resistor in there. Because if you don't, because if you want to have a silent alarm, which sometimes you can just put 300 ohm resistor or 10 kilo resistor. That's fine in there, and the system is not going to give you any trouble messages that the siren is disconnected. Sometimes, yes, you want to have a silent alarm. You just want that thing to communicate with something that's called a monitoring station. The monitoring station is going to go to the procedure, and whoever the burglar is might not even know that the alarm system is there, and might not know that the alarm systems has triggered, and all of a sudden there are police at the door. Okay, so that's awesome. Now there are some here program terminals, and they are depending on the system. Sometimes they provide a ground connection, or sometimes they provide a power connection. You have to read the manual depending on the model of the alarm system, what it actually does. It either provides power, 12 volts, or it provides connects things to ground. And based on that, you would connect whatever circuitry you want to connect, usually to a relay or something like that, to interface this with other things. So this is an output. Here, these 1, 2, 3, 4 program terminals, that's an output. And you can program each of those to follow a certain condition. Like, for example, you want to have some sort of light to be lit on to let you know when the system is armed. And so when the system is armed, you have, for example, that program says follow the arm condition or something like that. The other one, you can program that if something triggers, then you would have one of those activated. Right. So this particular board has 4 program buttons. Plus it has just a relay, which is almost like the program button. However, the program button makes an electrical connection with the rest of the board. This one here is just a relay that gives you a dry contact connection, and dry contact is an independent contact of anything, that's how relay works. So it activates relay, and you have the common terminal of the relay, normally closed or normally open. I'm not going to explain how relay works here in this class, but I would really, really encourage you to, if you don't know how relay works, just go and educate yourself on, or ask me during one of those labs. I can even demonstrate that thing to you, how relay works. Now we move on to this type of this connector right here. Here's the auxiliary power. And here is, oh, look, the bus bar. Okay. So auxiliary power, this one gives you a constant 12 volt DC on this. You use these terminals to power up your keypads, to power up your motion sensors, glass break detectors, whatever else detectors, or maybe some other smaller devices such as expansion board. That provides the power to it. And of course, it does have certain ampacity. So you can only connect certain amount of devices before this terminal says, hey, you're connecting too much to me. I can't handle that much. And it's going to lower, it's going to cause the voltage dropping, and maybe some things overheat. So you need to know the ampacity of that, and you just get that thing from the specification sheet that comes with whatever board you get. And then every device you connect, there will be a specs sheet with that to see how much current it draws. So as long as if you add all the active devices, as long as the amperage, the current draw, doesn't exceed the current availability on that, then you're good. If not, there are other external boards that you can buy and add that is basically has its own battery and it has its own auxiliary power, and you can have more power. And it does have its own backup battery, and it's charging the battery as we go along, because you're talking about the backup battery. So there are external power modules to add if you have more. And sometimes, yes, you need those external power modules. And over here, the green and yellow, see the Z cable, which we're going to talk about later on this presentation. I'm not sure if today we're going to have time or not. This is the communication bus. So, for example, the Z cable is the old color code, which is like, for example, Z4, as opposed to Z8 or Z16. So Z cable has 4 straight conductors, not twisted pair. You don't want a twisted pair for the alarm systems. Simply because a twisted pair acts as a coil. It has coil characteristics or inductor characteristics. And if stretched over a longer distance, and you're talking maybe 80 feet, 50 feet, 100 feet, it does have inductor, twisted pair does have inductance more than the straight pair. And then coils hate change. They do not like change. Inductors do not like change. If there is a sudden change, it is going to oppose that. So if you're connecting a door contact that detects the door being open, and it's just a reed switch, it's called a reed switch, just like the reed on a saxophone. You open the door and close it really fast, the signal might not get to the main board through a twisted pair. So you want a straight, untwisted pair for those. And the Z cable is just that, straight, untwisted, 4 conductors if it's a Z4. And the colors are, well, remember that red, green, black, and yellow? When we're talking about the pods, the old color system. So it also has the same colors. However, we use them a little bit different. We use the black and red for the power, and we use the green and yellow for the communication. Green usually is the ground reference, and yellow would be a signal type of a cable, conductor. So if you were running a wire to a keypad needs that communication wire. It needs to be connected to the bus where all the communication signaling happens between the keypad and the main board. Setting up the clock information, zoning information, what's open, whatever messages appear on the keypad. Plus, whatever messages you're sending through the keypad to the main board go through the bus. So you would connect the red and black to the power and connect that to the power terminals on the keypad, and you would connect the bus onto the bus connection on the keypad. And for your convenience, they labeled this, the engineers have labeled this green and yellow. And there is actually on the keypad also a terminal says green and yellow. So can't go wrong with that. And because it's a bus type of connection, you can connect many, whatever works with that particular system, you can connect that to the same bus, which is basically you're making a lot of parallel connections. That's how bus works. And through the modulation and frequencies, whatever the modulation protocol or the communication protocol is being used through that system, the main board, and the whatever devices, they work it out with each other. You don't have to worry about it. They just communicate through the same bus. So you can have multiple devices connected to this bus because that's how bus works. Moving on to the zoning connections. All right. Now, okay, you have common, common, common. These are the same points, and they are placed kind of strategically along this connector for our convenience. But it doesn't matter if you connect this common or if you use that common, they are the same point. This particular board is an 8-zone board, zone 1, zone 2, zone 3. What is a zone? It's a connection point. So let's say this is a zone 1. All right. So let's say that one is connected to the common. That will be the common. And I just made a ground reference. So take that with a grain of salt, but usually that's also connected to the ground. And let's say here is a reed switch on the door. And reed switch is basically a couple of connectors just separated like that. That would looks like a reed from the saxophone. And one is connected here, and one is connected here. And you get one going to the zone here, and the other one is connected to the common. When the magnet is brought in close proximity to the reed switch closes, completes the connection, completes the circuit, and that zone is just like connecting wire across that. So when the door is closed, the magnet is close to it because this here, the reed switch, you mount that on the door frame because there's wiring involved, no moving parts, frame, and then the magnet you mount it on the door. Easy, right? So when the door is closed, this thing is closed, the zone is at ease. When the door is open, the magnet is removed from the proximity, the switch opens, and the zone becomes open. And if it's not, if the system is not armed, it will let you know on the keypad that, let's say, the side door is open. Or if you try to arm it, the system is going to let you know you cannot arm the system because the side door is still open. So you have to go and close that door, and then the system is going to go into the so-called green light, lets you arm the system. And if the zone is open, when the system is armed, then depending on how things are programmed, let's say zone 1 could be on something that's called a delay zone, which means you have to have a delay zone when, for example, if this is a front door, the main entrance. So you come in, open the door with your keys, you open the door, so you are basically breaking the connection with that zone. You don't want that alarm to trigger right away because you're legit. You're supposed to work. This is your house. So usually the entry zones, like the front door or whatever, the door you're using to enter your house, they're put on something that's called the entry delay, which means usually you can program, you can change it. By default, usually it's at 30 seconds. You have 30 seconds to punch in the code. And then, boom, nothing happens, da, 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 da. If within the 30 seconds you don't punch the code, then kaboom, the system goes into the triggers into alarm, makes noise or doesn't, communicates with the monitoring station, and so on. Zone 2, zone 3, so you can combine, like for example, if you have 3 windows in the living room and you want to arm them, you're not going to put window 1, window 2, window 3 because you're going to run out of zones quickly. Right? So you can put all the windows, maybe they're on the same wall, or the living room windows you can put on zone 2, for example. You can put all the downstairs motion sensors on zone 3, unless you want to separate certain motion sensors because you need to separate certain room from certain room. And things like that. You can put all the glass break detectors in one room on zone 4. You can put all the other glass break detectors from maybe some other part of the maybe garage or something on zone 5. And this is, you can work things out. Some of the zones can be programmed as instant or delayed, which I explained. And some of the zones can actually be programmed as fire zones, which means if it's a fire zone, let's say put zone 8 and you put your smoke detectors on that zone, then that zone is not dependent on the status of the system, whether it's armed or not. It is, if that zone triggers, the alarm is going to trigger whether it's armed or not, because it's a fire zone. You don't need to arm the system to be able to detect fire. Actually, you should not have to do that. So different types of zones, and this is just a couple of zones that I mentioned. Plus the delay zones. You can program any zone as an instant or delayed. You can program some of them as fire. There's a list of zone types that you can choose from while doing a programming. So that's why programming from keypad, it's a treacherous process, and I would just not recommend with these new systems because it's just too complex. Have a laptop with all things on a display, and you can just click your way into different screens and set things up properly. Right? So we have just finished. Now, usually when there's a test week, I don't have any new theory content. However, with this fire security and surveillance, I always found that I had to rush through things. So yeah, I'm using this cushion time right now, that we can just go through these at like a normal pace. And if anybody has some questions, or maybe I could explain some things to more depth, I can, with all the comfort that we have. Okay, but it's 10:52 right now, so you guys have to go to another class, and this is the end of the regulation time for the class. So I will see you, this group here on Friday tomorrow, which is actually this is for the class of 2025, and possibly during some labs. Otherwise, have a great weekend. Enjoy your weekend, ladies and gentlemen. And as always, this is almost Friday. This is Professor Bark signing out.